Yes, hello everyone. Um, just a second. I hope the screen is visible clearly and my voice. And few of the students are asked to explain this. Okay, right. Okay, just a second. Still at this time, forwarding the message to some students. Yeah, okay. Yes, the question is six similar bulbs are connected as shown in figure. Yes, guys. Six similar bulbs are connected as shown in figure with a D and zero internal resistance. And zero internal resistance. Full stop. The ratio of power consumption by the bulbs when all are glowing and in the situation when two from section A and one from section B are glowing will be right. So you can note down the question and you can draw the circuit diagram also, the figure and options. This is the figure. In section A, three bulbs are connected, and in section B, three bulbs are connected in this fashion, which are in turn connected to a DC source of EMF E with internal resistance 0. With internal resistance 0. Right. Now, you are asked to find what? The ratio of power consumption by the bulbs. Ratio of power consumption by the bulbs in two cases. First case, when all bulbs are glowing. How to treat this when all bulbs are glowing? So let me explain this here. When all bulbs are glowing, the situation you have to treat like this. Yeah, you can take the first case. Yeah, what is that? First one. You can take it as bulbs are glowing. You have to consider the combination as shown in figure. When all bulbs are glowing, the combination can be the circuit. You can say how this combination circuit looks like. The circuit in all bulbs this acts like identical resistors connected in this fashion. This further can be redrawn or simplified to this form. What is this like a, you can say this left, so this is section A, mentioned as section A, and this is mentioned as section B part. Under A, three bulbs are connected in parallel, so the what is that, resultant resistance of the resistances under section A can be taken as R by 3, and this is under section A. Under section B, again three resistors are connected in parallel. You can consider the equivalent of those is nothing but R, the cell of EMF, DC source of EMF volts. This further you can reduce as a single resistor of equivalent resistance 2R by 3, 2R by 3, which is connected to the cell of EMF E volts. The question is, What is the power consumption when all bulbs are glowing? When all bulbs are glowing, every bulb's resistance is acting like a resistor combination of the figure 2. Oh yeah, I can say this is figure 2. Right. Is equal to, usually power consumed is equal to V square by R. When you know the resistance and the what is that, supply voltage is given, you can take it as a supply voltage square by resistance. Here in this case, figure nothing but R equivalent, nothing but R equivalent. Supply voltage is nothing but EMF of the DC source. So you can take this as E square by R equivalent. R equivalent of the combination of resistors in figure 2 is nothing but 2R by 3. This is the one. So you can take it as 2R by 3. 2R by 3, that 3 goes here and it becomes 3E square by 2R. You can take it as equation 1. Whereas the next scenario, that is case 2. In case 2, it is given that, what is given here in case 2? In the situation when two bulbs from A and one bulb from B are glowing, means you can visualize that two bulbs only are glowing, means two resistors are existing under section A, like this, in under section A. Okay, so we can connect them like this under section A. And under section B, only one bulb is, under section B, only one bulb is glowing, means only one resistor is playing the role. You can consider its resistance is R, this is also R, this is also R, because all are identical ones. So this is connected to the DC source of EMF E. Now you can say this is figure 3. Here, so in this case, power consumed, if you want to find power consumed is equal to, in second case you can say P2. Usually in terms of the EMF or voltage, supply voltage is E here, and resistance, you can express it as V square by R. Here supply voltage square by R. Supply voltage is nothing but E square by R. You have to take it as equivalent resistance of the entire combination. With this is section A, this is section B, and of course these are connected to the DC source of EMF E volts. Now this is identical to a single resistor of a R equivalent resistance connected to the same DC source. So what is the 2R, and P2 is 2 E square by 3R. So E square, R gets cancelled. We'll get 3 into 3, 9. 2 into 2, 4. So the ratio of power consumption in both cases is equal to 9 by 4, or 9 is to 4. I hope it is clear for you guys. You can go through this, everyone, and note down and practice. If you have further any confusions, or if the voice is not clear at any portion, you can ask me so that I can re-upload once again. Okay then, guys, take care. I may upload few questions related to Wheatstone bridge and meter bridge application based video.